Okay, question 1. We've got a particle initially at rest on a rough horizontal plane, so friction will be involved. We've got to find the magnitude of the normal reaction force. Then we're given the coefficient of friction between the particle and the plane, and we've got to work out pulling forces and so on. Okay, this is the setup for part A, and we've got to find the value of the reaction force. As there is no acceleration in this direction, the particle, in other words, is not leaping off the plane in any way, these forces must be in balance. So if I resolve upwards, I'm actually applying F equals ma, but of course A is 0. And I can say that R must be equal to 0.5 g. And not surprisingly, that's just worth 1 mark. Okay, part B. We've got a horizontal force now applied to the particle, x newtons, and we are told the coefficient of friction, and the situation is in limiting equilibrium. Find the value of x. Okay, I've added those forces to the diagram. Here's x, the pulling force, and friction trying to oppose the motion. Now, because we're in limiting equilibrium, the particle isn't moving, so there is no acceleration. Again, when we apply F equals ma, the ma part of it is 0, so the forces just must balance. So if I resolve now horizontally in the x direction, positive x must equal F. And as we are in limiting equilibrium, this must be equal to mu r. Mu is equal to 2/7. And R is 0.5 g. So if I substitute all of that in, I get that x is equal to 2/7 multiplied by R, which is 5/10 multiplied by g. 2 goes into the 10, leaving 5, and then 5 cancels with 5. This is simply equal to g/7. Which of you use g as 9.8? This is simply 9.8 divided by 7. And that's the answer.